Lastly, I'd like to review two very cool and handy features that are available in Simulation Professional, and that's first 2D simplification. So the ability to take a solid model and cut a section through it and analyze in 2 dimensions, or we can just start out with a sketch and start from there, and we can run pretty complicated analysis very quickly with a lot of detail and high refinement in the mesh, and run very fast. So sections that are very thin or long with a constant cross section, or items that are axisymmetric, are all available for 2D simplification. And I'm going to combine this using our optimization tool. In optimization, we can have sensors in the model that track displacements, stresses, and strains, and forces through connectors, and then we can change feature or sketch parameters and use our optimization solver to determine which direction the design should go to meet stress, deflection, or frequency targets. We can run multiple analysis at once, frequency and thermal at the same time as a stress analysis. So in this model I have two different stress analysis. One, I have a force acting underneath a snap fit representing a pull apart force after my parts. This could be for a housing that we're snapping together, so this represents the forces pulling the design apart, and I want to minimize the amount of horizontal displacement of my snap under these types of loads. Also make sure that I meet maximum stress criteria, and so this analysis is just based off of a two-dimensional sketch. And then I also have an assemble load, and I am looking at applying a force and having a minimum displacement of the snap such that my assemble force is under a certain limit, but my pull apart force is over another limit. And so we have a design study already set up in this model, and the variables for this model are the thickness of the snap, and so this is just a sketch parameter, the inner radius of the snap, and then the height of the snap. And we want our constraints are that the maximum displacement under the pull apart load meets a certain range. Our displacement under the assemble load has to be less than a certain amount. Our stress has to be under a certain level for the pull apart analysis, and then our goal is to minimize the stress value during the assembly analysis. So let's say we're repeatedly assembling this, and so we want to keep the stress under a yield strength for the snap fit, or for the material. In this case it's nylon. So we can take a look at our results view from the design optimization, and this runs very quickly. And let's hide the sketch so it's a little prettier. So this is our initial design, and we're looking at the stress from the assemble or the pull apart analysis. And then as we walk through the model, we can see that we get the results from the different iterations. And the iterations in red, we didn't meet all of our criteria. And then the iterations that are gray, we met our criteria, but they're not optimal. In addition, we can create and review trend graphs. So in this case we're looking at the displacement of the snap in the X direction, or left and right in this case, looking at that as a function of snap thickness. And then we're also looking at the assemble displacement as a function of the inner radius. So we can grab a whole lot of insight into our designs, and they can run extremely quickly. So we can just restart this study and see that the analysis runs almost instantaneously. running 2 different stress analysis at a time. And instant gratification. So as we see, no smoke and mirrors, no man behind the green curtain. We can use 2D simplification and optimization together to get a whole lot of work accomplished in a very short amount of time.